Okay, we're going to finish up lesson 3.1 by actually solving a system of equations by graphing. So we're going to start from scratch. My system of two linear equations is given by the equation negative x plus y equals 3 and the equation 2x plus y equals 6. So I'm going to start with the first equation. Again, highlighters worked for me, so I'm going to use highlighters again. We will first graph this first equation, negative x plus y equals 3. I'm going to start by creating a table, and I'll do a three-part table. And remember, I only need really 2 points to create a line. So I'm going to pick the value of 0 for x. When I put a 0 in for x, I get y equals 3. So I have 0 plus y equals 3, giving me y equals 3. So that's the first ordered pair I'm going to plot. The second ordered pair, I'm going to put a value of, let me pick 2. So I have negative 2 plus y equals 3. Well, that would give me a value of 5 for y. Negative 2 plus 5 is equal to 3. So therefore, that ordered pair would be 2, 5. So I'm going to plot these 2 points, 0, 3, and 2, 5. And I'm going to use a straight edge. Very important that you use a straight edge when you're doing your homework for this lesson. I use a straight edge, and there is my line that goes with the equation negative x plus y equals 3. So I'll use a highlighter to show that line in yellow. Now I need to graph 2x plus y equals 6. I'm going to use the same value for x. I'm going to use a 0 because 0 is a very helpful number when you're creating a table. 2 times 0 is 0. 0 plus y equals 6. That would give me 0, 6. I'm going to go right ahead and plot that point. 0, 6 would be that point right there. And then I'm going to use, again, the value of 2. 2 times 2 plus y equals 6. Well, that's 4 plus y equals 6. 4 plus 2 equals 6, so y would have to equal 2. So when I put a 2 in for x, I get a 2 for y. And now I'm going to create that line going through those 2 points. And I'm going to highlight that equation in green. I'm going to highlight that line that matches the equation in green. Straighten it out just a little bit here. There we go. And now I'm going to look for the point where they intersect. And it looks like they intersect right there. And that point would be 1, it appears, 2, 3, 4, 1, 4. So it looks like the solution is 1, 4. But how could we verify that that's the solution? Well, I'm going to put a 1 in for x and a 4 in for y. And the first equation is true, negative 1 plus 4 is equal to 3. I'll put a 1 in for x and a 4 in for y, 2 plus 4 is equal to 6, it makes the second equation true. So our solution is indeed the ordered pair 1, 4, meaning that x is equal to 1, y is equal to 4, and that's how we get the ordered pair 1, 4. So we're going to try one more. When you print out these notes, you should see that we've got some steps here, and they go right along with the steps that I've just done for you. Let's do the next problem. I'm not sure what I just did there, but I don't want it to be there when I print out these notes. So I'm going to move this back over here and move to the next problem. Okay, estimate the solution for the linear system by graphing. This is interesting how it says estimate the solution, whereas this previous problem said solve the system. So estimate is leading me to believe that maybe we're not going to get a solution that lies on a lattice point. A lattice point is a point in which the ordered pair has integer values. So if it's not integer values, that means that there might be fractions involved. Decimals is another way to think of that. So let's look at this. I've got x plus 2y equals 2. So I'm going to create a table. I've got an x value, x plus 2y equals 2, and I'll have a y value. And I'm actually going to color code this in a little different way. I'm going to call this red, and we'll do this equation in blue. And I'll create another table so that I can create that line, 2x minus 3y equals 12. So let's look at this first one. I love using 0. So I'm going to use 0 first. When I put a 0 in for x, I get 0 plus 2y equals 2. Well, 2y equals 2 means that y has to equal 1. If I put a 2 in for x, I get 2 plus 2y equals 2. 2 plus, I'm going to have to add 0 to keep that equation true. So that means that y would equal 0. So my ordered pairs are 0, 1, and 2, 0. 0, 1, and 2, 0. And I'll create a straight line using a straight edge. A straight edge is the only way that I can get as accurate as possible without using algebra. So there's our first equation graphed. Our second, I'll put a 0 in for x, and I get 2 times 0 minus 3y equals 12. That would be negative 3y equals 12, therefore y would have to equal negative 4. 0, negative 4. And if I use a 2 for x, I would have 2 times 2 minus 3y equals 12. Well, this is going to get me a fractional answer. I'm going to come over here and show you. I have 4 minus 3y equals 12. I subtract 4 from both sides, and I get negative 3y equals 8. Divide both sides by negative 3, and y is equal to negative 2 and 2/3. So when I put a 2 in for x, negative 2 and 2/3 would be that point right there. Now I'm going to show you how you can confirm that you're somewhat accurate here. It looks like had I put in for x, had I chosen, it looks like if I had chosen a 3 for x, I might have gotten out on a lattice point. So I'm going to come over here and I'm going to do that just to double check that I'm doing everything accurately and that my answers make sense. If I put a 3 in for x, I would have gotten 2 times 3 minus 3y equals 12. Well, 2 times 3 is 6. 6 minus 3y equals 12. If I subtract the 6 from both sides, I would have negative 3y equals 6, making y equal to negative 2. So if I had put a 3 in, I would have gotten a negative 2 out. So my line does appear to be accurate. So now what I'm going to do is I'm going to go to the intersection point. So the intersection point is right here. Now, as much as I'd like to move it so that it is at 4, negative 1, it's not there. This is some kind of a fractional answer. This looks like it might be, I mean, my guess would be maybe 4 1/5 and negative 1 1/5, but I'm not quite sure. Maybe 4 2/10, maybe 4 3/10, maybe 4 and a smidgen. So it's approximately 4 comma negative 1, but it's a little bit more than 4. And it's definitely less than negative 1, meaning that it's going to be negative 1 point something. So less than negative 1, if you have to think about this, less than negative 1, negative 2 is less than negative 1, negative 3 is less than negative 1, negative 4 is less than negative 1. All of these values down here are less than negative 1. So it's actually less than negative 1. And it's a little bit more than 4, a little bit less than negative 1. It's approximately 4, negative 1. This is an example of where algebra is required. Either algebra or a graphing utility, a graphing calculator. So this is a great example of how we use algebra instead of graphing to solve systems of equations, and how helpful that algebra really is to actually solve systems more accurately than what we've done here. I hope that you found this video helpful, and good luck on your homework. Your homework will consist of problems where you are solving using graphing. So all of your homework problems will consist of solutions in which there is an answer that lies on a lattice point, meaning integer coordinates. And we'll move on to the algebra in the very next lesson, lesson 3.2. Good luck!